Hello students, welcome back to another video of MATHIPHY. In today's video, we will do paper 2, a multiple choice paper of course code 0625 from month May-June 2025, variant 1. Question number 1 says, speed time graph for a racing car is divided into 4 sections P, Q, R, S. The car starts the race but soon crashes into wall of tires. Y side is speed and X side is time. Which section of the graph shows that there is an acceleration that is changing? If we see velocity time graphs, when the line or curve is straight, this shows that the acceleration is either zero or it is constant. When VT graph shows curves like this, or it can be a decreasing gradient like this and this shows that the acceleration is changing. Either the acceleration is increasing or decreasing, or deceleration is decreasing or increasing. So the key is that if velocity time graph show curves, that means acceleration is changing. So P is a straight line, that means acceleration is not changing. Q is showing a curve, that means acceleration is changing. Again, R is also showing a curve, so acceleration is changing. At S, we have a straight line, so acceleration is not changing. That means option C, Q and R only. Second question says the diagram shows 4 forces acting on aircraft. 40 kilonewton this side, 60 kilonewton this side, 120 kilonewton above and 60 kilonewton down. Which arrow shows the direction of the resultant of 4 forces? The 40 kilonewton will be cancelled out with the 60 kilonewton at right, and there would be only 20 kilonewton of force acting at right side. This 60 can be cancelled out this 120 kilonewton, and there would be only 60 kilonewton of force acting upward. Now to get the resultant, it would be like this. So it can either be A or B. But how can we choose? For this, we will find the angle between the resultant and x-axis. To get the angle, we use the formula theta is equal to tan inverse of y component of force divided by x component of force. Now putting the values, it would be tan inverse of 60 kilonewton, that is acting on y side, and 20 kilonewton, that is acting on x side, and the angle would be 71.5 degrees. That is a much larger angle, so A can't be the choice because A has lesser angle, so B is correct. Option B. Third says the diagram show the metal block X and Y suspended from identical force meter. X and Y have identical dimensions. Which statement about XY is correct? We are using force meter and it is used to measure the weight. And as you know, the weight of this block is 20 Newton and the weight of Y block is 30 Newton. That means both have different weights. So either option A is correct or D. B and C both are wrong. And the question says that the boxes have identical dimensions. That means their length, width and height is same. So the volume of the boxes would be same. So option D says that they have equal volumes. That means option D is correct. Fourth question says a girl has a gold necklace. Which apparatus does she need to find the density of the gold? To get the density of something, we use the formula density is equal to mass divided by volume. To get the mass of the gold necklace, we use a balance. To get the volume of the necklace, as it's an irregular shaped body, we are going to use a measuring cylinder. That means we need two things, a balance and a measuring cylinder. Option C. Question 5 says, a spring has a length of 25 cm when a load of 2 Newton is suspended from it, and it has length 35 cm when 7 Newton is used. What is the spring constant of the spring? So the stretch length is 25 cm when the load is 2 Newton, and the stretch length is 35 cm when the load is 7 Newton. So 7 minus 2 would be 5 Newton. So if we hang 5 Newton, then 35 minus 25, 10 centimeter would be the extension. So this is force and this is extension. Now to get spring constant, we can use Hooke's law, which says that spring constant is equals to load divided by extension produced. So the load is 5 Newton and extension produced is 10 centimeter. Dividing them both, it would be 0.5. That is option B. Question 6 says the diagram E to H shows a block of wood on a frictionless surface. In each diagram, the block has two forces acting on its side. Which diagram shows the block is in equilibrium? Being in equilibrium implies two conditions: that the net forces on the body should be zero, or sum of forces on a body should be zero, and the net moment on the body or sum of torques on the body should also be zero. In E, 2 Newton of force is acting this side and 2 Newton is acting this side. Their line of action is in a way that it will cause rotation. In F, 2 Newton and 2 Newton both are acting towards left, so it will create a total of 4 Newton force towards left, so it will not be in equilibrium. For G, this left side is negative 2 Newton, the force on right side is positive 2 Newton, both will cancel the impact of each other and the total of 0 Newton force will act and the body will be in equilibrium. For H, this force is negative 2 Newton, let's suppose, so the other direction would be positive 2 Newton, both will cancel each other and the sum would be 0 Newton. That means H is also in equilibrium. So D is correct, G and H only. Question number 7 says, which statement is not correct? A part says the momentum of a system is conserved in all interactions. Yes, if the system is isolated, the total momentum before interaction is equal to total momentum after interaction. B says that impulse is equals to change in momentum. Yes, change in momentum is equals to the product of force multiplied by the time of interaction, which is basically impulse. So B is also correct. Now C says force acting is equals to change in momentum multiplied by time. If we rearrange the above equation for force, it would be change in momentum divided by time of interaction. It is not multiplied by the time, it's divided by the time. So C is not correct. Question 8 says a force acting on a moving ball causes its motion to change. The force stays constant. What makes the force produce a greater change in motion of the ball? The motion to change means that it is changing the velocity or it is accelerating the body. We want the force to stay constant and the change in motion to be greater as possible. You know that Newton's first law says that force is equals to ma. If the force is constant and I rearrange the equation, it would be acceleration is equals to force divided by mass. And as the force is constant, so I can remove it by the sign of proportionality. So acceleration is inversely proportional to mass. If we want to increase the acceleration, we have to reduce the mass of the object or the ball. So decreasing the total mass of the ball. Question 9 says a farmer has two carts. The carts have same weight, but one has 4 narrow wheels and the other has 4 wide wheels. Which cart wheels sink less into soft ground and what is the reason? Both wheels have same weight, that means they will exert equal force in the downward direction and produce pressure. Pressure is defined as force per unit area. Now if the force for both of the carts is same, so I can remove this force with the proportionality sign. So pressure would be inversely proportional to area. Now if we see wide wheel, the area of contact with the ground is greater. If the area is greater, the pressure would be less. So it will exert less pressure on the ground and will sink less. So the cart wheel which is wide will sink less, and the reason is because less pressure on the ground. Option D. Question number 10 says a hot gas and a cool liquid are at same pressure. Which row describe the separation and the motion of the particles of hot gas compared to cool liquid? So we have a hot gas and a cool liquid, and both are having same pressure. Talking about the hot gas, the separation between the molecules would be greater because the temperature is high and the kinetic energy would be high and there would be expansion. So it would be greater than in a liquid. Also, if the kinetic energy of molecule is high because of the temperature, so motion would also be faster than a cool liquid. So option A is correct. Question 11 says a fixed mass of gas has a volume 1.2 meter cube and pressure 200 kilopascal. The gas expands at constant temperature to the volume 1.8 meter cube. So initially the volume is 1.2, so let it V1, and the pressure is 200 kilopascal, so it's P1. Then the gas expands at constant temperature and the new volume is 1.8 meter cube, so let me call it V2. We have to find the new pressure, that means pressure 2. For this we can use Boyle's law, which says that P1 V1 is equals to P2 V2, or product of pressure and volume is constant. Making P2 the subject, it would be P1 V1 divided by V2. Now I will plug in the values. 1.2 times 200 divided by 1.8, and the answer would be 133.3. To two significant figures, it would be 130 kilopascal. Now question number 12 says the specific heat capacity of solid P is greater than of solid Q. What does this statement mean? Specific heat capacity is basically the energy supplied to unit mass or 1 kg of mass to rise its temperature or to change its temperature by 1 degree Celsius. Now, if the P has greater specific heat, that means it requires greater amount of energy to rise the temperature of 1 kilogram by 1 degree Celsius, and the solid Q needs less amount of energy for the same procedure. If we read all the statement C, more energy is needed to rise the temperature by 1 degree Celsius of unit mass of solid P than unit mass of solid Q, matches with the definition, so C is correct. D is not correct because it says more energy is needed to melt unit mass of solid P than unit mass of solid Q. We don't see melting in specific heat. We are just supposed to raise the temperature by 1 degree Celsius. So it's not correct. Now 13 says when water vapor evaporates, what escape from the surface of water? Individual atoms? No. Individual molecules? Yes. A one complete molecule of water, which is H2O, leaves the surface of water. Question 14 says a sealed container of gas is heated and the pressure of gas is increased. Which statement explains the increase in pressure? If a sealed container is heated, the temperature of the container will rise. Due to the increase in temperature, the kinetic energy of the molecule will also increase. And due to increase in kinetic energy, the particles will start moving more faster and will hit the walls of the container more often, due to which they will exert more force on the walls of the container. More force means greater pressure. A option says the forces of gas particles striking the walls of the container increase. Yes, the force increases because molecules are colliding with the walls more often. B says the force of attraction between gas particles of the wall container increases. No, because kinetic energy is increasing, so the attraction will reduce. B is not correct. C says the gas particle collide with each other more frequently. Yes, they collide with each other more frequently, but this doesn't have any impact on the pressure on the walls of the container. Now D says the gas particles lose more energy when they strike the walls of the container. The pressure is not due to the fact that the molecules are losing more energy, it is only due to the more frequent collision of the molecules with the walls of the container that is causing the force to increase and the pressure to increase. 15 says a student has a copper rod and a wooden rod. Both rods have same dimension. The student puts one end of each rod in beaker of crushed ice. After few minutes, the student picks up the rod at the end not in the ice. Which statement is correct? So he's going to dip a copper and a wooden rod in the beaker containing an ice and give it some time, and after some time he will pick the rods. The copper rod is a good conductor and a bad insulator, and a wooden rod is a bad insulator and a good conductor. So copper will conduct the temperature to the end, so it would be cooler. Option A says the copper rod feels colder than the wooden because copper is a better conductor than wood. Yes, it is correct. Option A. Question 16 says the diagram shows a black object X at constant temperature. The arrows represents the absorption and emission of thermal radiation at surface. Object Y is at same constant temperature as X and is identical except that it has white surface. Which row correctly compares X with Y? So this is sphere X and these arrows are showing absorption and emission of the thermal radiations. And we have identical sphere Y that is white in color. If we compare the thermal radiations pattern, the black is a good absorber and a good emitter of thermal radiations, but the white color is opposite to it. It is a poor absorber and a poor emitter of thermal radiations. So it will absorb and emit the radiation poorly. So the rate of absorption of X would be higher than Y and the rate of emission of X would also be higher. So option A. 17 says the diagram shows a cork with weight attached so that the cork floats upright in water. This is cork and this is a thread and weight is attached to the thread. The transverse waves travel across water from X to Y. In which direction do the wave makes the cork move? Transfer waves are the waves in which the particles of the medium vibrate perpendicular to the direction of propagation of waves. So if the wave is traveling from X to Y, that means in this direction, the particles will vibrate perpendicular to it, that means up and down. So the cork will also move up and down like this. So option B is correct. Question number 18 says, a thin converging lens is used as magnifying glass. How does the image compare with the object? If we see image formation by converging lens, it acts as magnifier when the object is between lens and focal point. In this case, the image produced is the magnified image. And the properties of the image are that it is virtual, it is enlarged, and it is upright. So, option D, the image is virtual and upright. 19 says the diagram shows two plane mirrors at 90 degrees to each other. A ray of light is incident on one of the mirror. The ray reflects off both mirrors before reaching a screen. At which labeled point does the ray reach the screen? So this is the ray of light. When it will hit the first mirror, it will reflect off in this direction, because the angle of reflection should be equal to the angle of incidence. Now after reaching the second mirror, this is the normal of the second mirror, the ray will again reflect and it will reach the point B. because the angle of incidence and reflection would again be equal. So B is the correct option. 20 says the speed of light in material is 50% of speed of light in air. What is the refractive index of the mirror? Speed of light in air is 3 into 10 raised to power 8 meter per second, and speed of light in the material would be 50% of it, or we can say half of it, so it would be 1.5 into 10 raised to power 8 meter per second. To calculate the refractive index of the material, we use the formula that refractive index is speed of light in air divided by speed of light in that medium. So speed of light in air is 3 into 10 raised to power 8, and speed of light in medium is 1.5 into 10 raised to power 8. Dividing them both, I will get the answer of 2. So option B is correct. Question number 21 says a beam of white light is split into spectrum of 7 colors. Which name is given to this process? A white light when falls on a prism is split into 7 colors, and this process of splitting is known as dispersion. That means option B. Question number 22 says satellites are sometimes used to receive and retransmit television signals. Which row shows the type of satellite and electromagnetic waves used? So type of satellite would be geostationary satellite because it appears to remain in fixed position in the sky relative to the point on Earth's surface. And the type of wave would be microwave because they can pass through Earth's atmosphere with minimal absorption, unlike infrared, which are absorbed by the Earth atmosphere. So D is correct. 23 says a sound wave travels through air and strikes the solid block of steel. Some of sound is reflected from steel and some is transmitted through steel. How does the speed and wavelength of sound in steel compare to the speed and wavelength of the sound in air? If it is transmitted into the steel, this process is known as refraction. And in the process of refraction, the frequency is constant. If we try to figure it out with wave equation, which is velocity is equals to frequency times wavelength, and frequency is constant in this process, so velocity would be directly proportional to wavelength. And the wave is going from less denser medium air to more denser medium steel, so its velocity is going to increase. So increasing the velocity would also means that its wavelength would increase. So speed in the steel would be greater than in the air, and wavelength would also be greater than in the air. That means option D. 24 says the diagram shows a bracelet containing two magnets. The arrows represent the pattern and the direction of magnetic field due to magnets. Which row identifies the magnetic pole at J and the magnetic pole at K and where the magnetic field is strongest? If we see a bar magnet, its magnetic field is like this. The magnetic field lines exit from North Pole and they enter the South Pole of the magnet. And the magnetic field is strongest where the magnetic field lines are closest and it's near the poles. If we see the bracelet, all the magnetic field lines are exiting. So that means both poles are north poles, and X point is the point where the magnetic field lines are closest and the magnetic field is strongest. So option A. 25 says which row describes the electric field and its direction. If we talk about the definition of electric field, it is the region in which electric charge experiences a force. Now the direction of electric field. Consider that we have two charged plates and there is electric field between them in the direction shown. If there is a positive charge, it would be attracted towards the negative plate. And if we have a negative charge, it would be attracted towards a positive plate. That means that electric field has same direction as the direction of force experienced by a positive charge. So the direction of electric field is the direction of force on a positive charge, option A. 26 says copper wire is available in fixed length but in various diameter. Each wire has different resistance R. Which relationship between R and D is correct? R is directly proportional to length. R is directly proportional to temperature. R is inversely proportional to the cross-sectional area of wire. And in most of the cases we have a cylinder wire, that means cross-sectional area is a circle whose area is pi r square. And in terms of diameter, it is d over 2 square. According to this, the resistance would be inversely proportional to the square of radius, or resistance would be inversely proportional to the square of diameter. All the other terms are constant. So R is inversely proportional to square of diameter, option D. Question 27 says the diagram shows three 20 ohm resistors R1, R2 and R3, and switch S is connected to DC power supply. Switch S is open. The potential difference across R3 is 9 volts. What is the potential difference across R3 when switch is closed? So right now the switch is open, that means R1 is not in the circuit, and the circuit would be like this, having R2 and R3. And it's a series combination, so total voltage of battery is going to split across R1 and R3. Now R3 is getting 9 volts of voltage, and R2 is identical to R3, so it will also get 9 volts of voltage. So 9 plus 9, 18. That means total voltage of the battery is 18, that is going to split in 9 and 9. So we come to know that the battery is 18 watt. Now we are going to close the switch, and after closing the switch, R1 would also be involved in the circuit. The resistance of R1 is 20, R2 is also 20, and R3 is also 20. R1 and R2 are in parallel combination with each other. That means their equivalent resistance would be 1 over 20 plus 1 over 20, which would be equal to 1 plus 1, 2 over 20. And after simplifying it, it would be 1 over 10. That means their equivalent resistance is 10 ohms. Now the circuit looks like this. Again, it's a series combination, so we can use the ratio method to calculate the voltage across R3, which is the simpler one, which shows that R3 is having 20 proportions out of total 10 plus 20, 30 proportions of 18 volts of battery. So answer would be 12. If we don't want to follow this method, no problem, we'll go with the conventional method, for which we first calculate the current traveling in this series combination. For current, I will use the Ohm's law, V equals to IR. The current I would be equals to V divided by R. The total voltage of the battery is 18 divided by the total resistance of the circuit, which is 30, and the current would be 0.6 amps. As it's a series combination, so both of the resistor will get the same amount of the current supplied by the battery, so 0.6 amps. Now to get the voltage across R3, again I can use Ohm's law because I have the current and resistance. So V equals to IR. I is 0.6 and R is 20. Multiplying both, the voltage would be 12 volts again. So option C is correct. You can use either method. 28 says the circuit shown include a DC power supply, one diode and two LEDs. In which circuit will both LED turn on? If we see A, the current will flow from first LED because its direction is accurate, and the current will flow from the diode as well, but the current is not able to pass through the second LED because it is in reverse direction, so option A is wrong. In B, the current will flow from the first LED, but the diode is in opposite direction, so it will block the current and the second LED will not lit. In C, the current will flow from the first LED and the diode and the second LED as well. Three of them are in accurate position, so C is the correct answer. 29 says a wire is connected to resistor R and it is moved in magnetic field. A current is induced in direction as shown. In which direction the wire is moved? We are moving the wire. That means we are applying force on the wire. To find the direction of the force, as it's an induced current, we are going to use the right hand rule of Fleming's. The direction of magnetic field is from north pole to south pole, that means towards the right side. The direction of current is shown by the arrow, that means it is towards us. Now, for applying Fleming's right hand rule, we are going to stretch the fingers of right hand perpendicular. The forefinger would be in direction of magnetic field, the middle finger should be in direction of current, and our thumb will represent the direction of force. Right now it's downward, that means the force that we applied on this wire is downward. Option C. 30 says which component is not found in AC generator? If we see the diagram, we have diagram 1 and diagram 2. In diagram 1, the rings that we have are complete circular rings that do not have any cut between them. These are used to connect the coil with the external circuit, and these rings are known as slip rings. And slip rings are used in AC generator. On the other hand, in diagram 2, the rings that we have has a little of cut between them. These rings are known as split rings. And split rings are used in DC motor. Split rings not only connect the coil with the external circuit but are also used to reverse the direction of current after every half cycle to reverse the direction of force so that the coil keep rotating. So according to our question, which thing is not found in AC generator? AC generator has slit rings. Split rings are not found in AC generators, they are found in DC motors. 31 says there is current in straight metal wire in the direction. So this is the I and the direction of current is upward. Which row describe the direction and the pattern of magnetic field due to the wire when looking from vertically above the wire? If we have a current carrying wire, there would be magnetic field around that wire, and to get the direction of that magnetic field, we use right hand grip rule, according to which we grip the wire with our thumb in direction of the current. So the direction of the current is upward, so our thumb will also be upward. This is the direction of our thumb. Now the curling fingers of our hand show us the direction of magnetic field. So fingers are curling in this direction. That means the magnetic field is also in this direction, which is a anti-clockwise direction. So the magnetic field is anti-clockwise and the pattern is circular. Option A. 32 says a simple transformer contains iron core. What is the function of iron core in the transformer? Iron core in the transformer is used to direct and strengthen the magnetic field, and it also concentrate the magnetic field to the secondary coil. Option A says to conduct current from primary coil to secondary coil. No, there is no link to conduct the current from primary to secondary. It enables the secondary coil to act as electromagnet. No. To ensure that there is high voltage between the primary and the secondary coil. The voltage is defined by number of turns. To link the magnetic field in primary coil to the secondary coil. Yes, it is used to direct the magnetic field, so D is correct. 33 says in an alpha particle scattering experiment, a beam of alpha particle is fired on very thin piece of gold foil. In which direction do most of alpha particles travel after hitting the foil? If we see the Rutherford experiment, he bombarded alpha particle towards gold foil, and most of the alpha particles went straight from the foil. That is because mostly atom is empty. Some of the alpha particles after repelled by positively charged nucleus, because alpha particles are also positively charged, so they deflected, and very few amount of alpha particles after having head-on collision with nucleus were bounced back. So most of the alpha particles went straight. The reason is because most of the atom is empty. 34 says an atom of boron contains 5 proton and 5 electron. The nucleon number of atom is 11. How many neutrons are there in the atom? The nucleon number represents the number of neutrons and the number of protons in an atom. So if out of 11 nucleon number, the number of protons is 5, that means the remaining 6 are the number of neutrons. 35 says a detector placed near a radioactive isotope give measured count rate of 800 counts per minute. The half-life is 3 hours. The background count is 32 counts per minute. What is the count rate of the detector after 6 hours? This 800 counts per minute is measured by detector, so it also includes the background radiation in it, which is 32 counts per minute. To get the counts from the source, we have to subtract the background radiations from 800. So the source is having 768 counts per minute, and the half-life is 3 hours. So that means after the passage of first half-life, or you can say 3 hours, this 768 radiation count would be reduced to half of it, and it would be 384 counts per minute. Now after the passage of second half-life, that means further 3 hours, or you can say the total of 6 hours, this 384 radiations would be reduced to 192. Now we are measuring it with the help of detector. So detector will again add the background count to this 192. The reading that we'll get in detector would be 192 plus 32, which is 224 counts per minute. Option C. 36 says sodium 24 is a radioactive isotope that emits beta radiation. Which nuclear equation shows sodium 24 decays? The beta radiation is atomically represented as the atomic number is -1 and the mass number is 0. So C and D are totally wrong because atomic representation of beta particle is wrong. Now if we see A and B, which of them is correct? For this we have to balance the mass number and atomic number on both sides of the equation. So for option A, the mass number of sodium is 24, and on the other side we have 24 plus 0. That is correct because equation is balanced. For atomic number, over this side we have 11, and on the other side we have 12 and -1. So 12 minus 1 is 11. That means this equation is also balanced. So option A is correct. If we see B, the atomic number over this side is 11, and over the other side it's 10 and -1, which will give you 9, and this will not balance the equation, so it is wrong. Now 37, which safety precaution must be taken by using source of gamma radiation? Reduce the distance between source and person. We have to increase the distance between source and person. Although gamma radiation are very penetrating, but reducing the distance will also worse the case. So 1 is not correct. If we see 2, it says that reduce the time of exposure to the radiation. Yes, if you reduce the time, less radiation are able to get into your body. Third says use a suitable shielding material. Yes, shielding material will block gamma radiation, so it will help. So option 2 and 3 are correct, but 1 is totally wrong. That means option D. 38 says a student defined 3 periods of time. The time Ts taken from Earth to orbit the Sun, Tr for Earth to rotate on its own axis, and Tm for the Moon to orbit the Earth. Which row shows the shortest and the longest time period? The Earth to orbit the Sun. Earth take 365 days to orbit the Sun, or we can say one complete year. Earth to rotate on its own axis, it take 1 day for Earth to rotate on its own axis. Moon to orbit the Earth. Moon take 28 days or approximately 1 year to orbit the Earth. Out of this, the longest period is Ts and the shortest period is Tr. So option B is correct. 39 says which statement about universe is correct? The universe contain million galaxies? No, it contains billion trillion of galaxies. Redshift is the decrease in observed wavelength of electromagnetic radiation emitted from receding galaxy. So when the galaxy is receding from Earth or going away from Earth, if it emits any electromagnetic radiation, as the radiation reaches Earth, its wavelength increases. And you have seen in electromagnetic spectrum that light with longer wavelength is red in color. That's why this process is known as red shift. So red shift is increase in the wavelength of the light, not decrease. So B is wrong. C says light emitted from distant galaxies appear red shifted. Yes, I have described the procedure. So C is correct. D says redshift of light from distant galaxy gives evidence that universe is contracting. No, it gives the evidence that universe is expanding. Question 40 says which statement about cosmic microwave radiation is correct? So CMBR are the radiations that are present in Earth since the Big Bang has been occurred, and the wavelength of CMBR is increasing and redshifting. So the option number C, which says that CMBR has shorter wavelength in the past, yes, its wavelength is increasing, so in past it has shorter wavelength. Thanks for watching the video. If it was helpful, please hit the like button and subscribe my channel.